Welcome to today's class. Don't forget again, I do remind you, as you are starting watching this class, don't forget to subscribe to this YouTube channel, Olusegun Maths Clinic. After you click the subscription, you also click the notification button. So anytime I'm releasing videos, you're able to see it. Today we are talking about the types of matrices. We have a diagonal matrix. A matrix with 0 entries only on the diagonal is called diagonal matrix. If you able to see, you see that this is 1 0 0 2 0 0 0 3. You see that it is this is what we call diagonal. So that's why we call it a diagonal matrix. In B part, it's also occurring in this form. So this is a diagonal matrix. That's what we call a diagonal matrix. We also have another types of matrix that are really common to what we need now. We have many types of matrix. We are only dealing with the waec, necos, and the jamb syllabus. That is why we try to limit the standards of the types. Identity matrix. A diagonal matrix whose non-zero entries are all ones is called an identity matrix. This is 2 by 2 square matrix. So it's an identity matrix. You realize that we have 1 0 0 1. This is 3 by 3 identity matrix. 1 0 0 0 1 0 0 0 1. So that is how it continues to have another one. We have square matrix. A matrix with equal numbers of rows and columns is called a square matrix. When they have equal number of rows and columns, this one have 1 row, 2 row, 1 column, 2 column. This one have 1, 2. This is row 1, row 2, row 3, column 1, column 2, column 2. So it has 3 rows and 3 columns. That's why we call it a square matrix. So the last types, before we go to some examples, is a known matrix. A matrix with all the entries being 0 is a known matrix or 0 matrix, whereby it has no values than 0. So that's why we call it a known matrix. So we like to solve. Before we go, there is one types of the one operations of matrix which we want to talk about, that the example starts from. So today we want to talk about the scalar products. It is part of the operations of matrix under the multiplication of matrix. This is the first thing you come across in multiplications of matrix. So for example, you have A to be 2, 8, 7, 10, 5. So find 2A. If A is this, to now find 2A, it's so very simple. You put 2, you write 2, 8, 7, 10. In the elementary part, it will just be 2 times 2, 2 times 8, 2 times 7, 2 times 10. This is what we call a scalar product. So 2A value will give you 4, 16, 14, 20. So that is how this is the meaning of scalar product. In case you have A, you now have 2a. Just multiply the 2 with all elements, because every of the numbers in matrix is called element, not numbers. Element. So element 4, element 16, element 14, 20. So you only use the 2 to multiply all. That is. So now I want to solve some example that is exactly jamb questions, so you're able to understand how this scalar product works. So this is an example. He said S is 1, 0, 1. All the element here. He said find 2x minus y. So this is an example of scalar product in matrix. So if you have to solve this, so very simple. You just say that 2 to multiply 1, 0, 1, 2 minus 1 is 0 minus 1 is 0, 1 into minus. So minus 1, 1, 2, 0, minus 1, minus 1, 2, 0, 1. So it's a normal equation, but the only thing will happen to this is that it will have to be increased because you multiply all this by 2. So we have 2, 0, 2, 4 minus 2 is 0, minus 2 is 0, 2. Now minus 1, 1, 2 is 0, minus 1, minus 1, 2 is 0, 1. So the final answer will now be 2 minus 1. So at this spot, it will give you 3. It will be 3 is 0 minus 1. It will give you minus 1. 2 minus 2 to give you 0. 4 minus 0 to give you 4. Minus 2 minus 1. So minus will multiply it to give you plus, to give you minus 1. Is 0 minus 1, that is plus 1. So the last row, minus 2 minus 2, that is minus 4. Is 0 minus 0 is 0. 2 minus 1, that is 1. So now this is the final answer of this question. And this question is a jamb question. As it is a thing you can solve within 5 seconds if you're able to know the logic behind this course. So just the scalar, an example of the scalar product in matrix multiplication. So this is another example that combine the scalar product and the matrix multiplication. We have been given P and I. I is 2 by 2 unit matrix, which I also call the identity matrix. So the answer is to find the value of P squared minus 2P plus 4I. You know, this is P. You firstly find the P square. P square will be 2, 1 minus 3 is 0. We're able to know that P square will be P in 2 ways. 2, 1 minus 3. So you just have to 2 times 2. We apply the rows and column. If you're able to study the last class, we explain more about how to multiply a matrix. The 2 will multiply 2, the row will multiply column, and you now say 2 times 2 making 4. 4 plus minus 3. it will be 4 plus minus 3. So that will be 4. So the row we also multiply this column, which will be 2, which will be 2 plus 1 times 0 plus 0. This one will start again. Minus 3 times this will give you minus 6. 0 times this plus 0. So this will be applicable to this again. Minus 3 times minus times 1 to give you minus 1. Minus 1 minus 3 plus 0. So if you are now to write, you say p squared is equal to 1, 2, minus 6, minus 6 and minus 3. So this is the value of p squared. So, but the value now said that, so also let's find the value of 2p. The 2p will be 2 on 2, 2, 1, minus 3, 0. 2p will be 2 times this, 4. 2 times 1, 2, minus 6, 0. So let's now, and the 4 high, let's find 4 high. You know, we have said early that I is 1, is 0, is 0, 1. So therefore we have 4 high will be 4, is 0, is 0, 4. So to now evaluate this value, we say that p squared minus 2p plus 4i. So you write everything. So our p squared is 1, 2, minus 6, minus 3, minus 2p. So our 2p is 4, 2, minus 6, 0. So, and the 4i is a plus 4i. 4i give us 4, 0, 0, 4. You discover that they all have same numbers of rows and columns. So this is the place to write final answer. 1 minus 4, making minus 3. Minus 3 plus 4, it will give you 1. Let me say it again. 1 minus 4, it will give you minus 3. Minus 3 plus 4 to give you 1. So let me write the 1 very well. So another one, 2 minus 2, making 0. 0 plus 0, we have 0. Minus 6 minus 6. Automatically, this will give you plus 6. This will give you 0. So minus 6 plus 6, making 0. 0 plus 0, we have 0. Minus 3 minus 0. Minus 3 minus 0, making minus 3. So minus 3 plus 4 gives you 1. So this is the final answer of this question. You can check your past question in Google or in any place you see this answer. Only thing they just want you to know that they want you to apply the matrix multiplications and the multiplication of matrix, that is scalar product and order. So from the example where we have started to summarize this class, we talked about the types of matrix, and we explain the type. We have scale, we have identity, we have diagonal, we have new matrix, which we're able to explain better from the beginning. We explain it, the diagonal, the new, the identity matrix. So we also solve an example that related to the scalar products. So this is how we saw this. If you're able to listen to this video very well, you get the rudiments and the fundamental way of solving these problems anytime you are meeting, even in post-jamb, in waec. So once again, don't forget to subscribe to this channel. Just click subscription button and the notification, so anytime I'm releasing video, you're able to see immediately. So thanks for watching this video. Please subscribe.